Okay, how can the graph be used to find the distance that the ball rolls before it hits the pin? Okay, now hopefully we know that the area under a velocity time graph is the distance. The sneaky bit I think here is it's before it hits the pin. Okay, so it's that time before 3 seconds, so we need to find the area of that shaded area there. Equation linking momentum, mass and velocity, that's an easy one for 1 mark. And then we need to substitute into this. Again, it's before it hits the pin. They've just given us the mass up here, so that's easy. We're going to need to look back to find the velocity. So from here you can see the velocity before it hits the pin is 6 meters per second. Substitute it in and the answer is 38.4. The units kilogram meters per second. Next question asks for the velocity of the ball after it's hit the pin, so we need to come back to this graph. Okay, and that should give us 4.8 meters per second. So then after the collision, the ball and the pin have got the same velocity, so now we've got to calculate the mass of the pin. So the key concept here is the principle of conservation of momentum. That means that the sum of all of the initial momentums is going to be equal to the sum of all of the final momenta. So let's think about before the collision first of all. We've got the momentum of the ball, which is the mass of the ball times by the initial velocity of the ball. Come on, computer. And also we've got the mass of the pin times by the initial velocity of the pin. Now you might already have realised that the pin was stationary to begin with, so because the initial velocity of the pin is 0, this term just disappears and we can get rid of it. So all of that on the left is equal to the sum of the momenta, the final momenta. Now it's just said that they've got the same velocity, so that means effectively that they're stuck together. So you've got the mass of the ball and the mass of the pin, because they're moving together, times by the final velocity. Now we've already worked out this term in an earlier part of the question, so that's straightforward. That's just 38.4 kilogram meters per second on the left. We also know the mass of the ball, which is 6.4 kilograms. The mass of the pin, that's the thing that we're trying to calculate, and then the velocity of the pin is the same as the velocity of the ball, so that's just 4.8. And again, you know, we'd already given that in that previous part of the question. So now all that remains is to put it all into a calculator, and you should end up with the mass of the ball of 1.6 kilograms. And that's it. End of the paper.